Hello everybody. This is just a kind of a random thing that I thought would be fun to show. Oh, I don't know, 25 or 30 years ago, I think it's almost 30 years ago. One of the things that I did when I was at Parker Guitars was I had access to parts, lots of parts to play with, and one of my favorite projects was to try and make a semi-hollow guitar that I liked, and because I'd always loved Gibson 335s, and you know, a lot of them are just awful, pardon me, but only a few are really good, and I had the opportunity to play a few really good ones, and they just blew my mind. So I was trying to figure out how to, you know, get involved with that idea of having a semi-hollow thing with a bridge that could move around a little bit, 330 or 335 kind of style. So anyway, here's one that that we put together. I put together with another builder in looks like 2009. Fred Copo from France came to my shop, and we had fun putting this thing together. And at the time, Larry Fishman was playing around with the first of the Aura thingies, and so we ended up with an experimental Aura thing that they provided that has 4 preset acoustic guitar sounds, 1 Gibson sound and 3 Martin sounds, and it's just great. Or you could just go piezo. Of course, there's a piezo pickup in here. And then this is the bridge style that I used on the classical string guitars that we made at Parker for a while. This one, I guess, is the most recent of these, and it isn't very recent, from 2013 or something like that. And this has just been kicking around the shop with a set of pickups that Bob Palmieri made that he wasn't completely invested in, and I don't know, the guitar just sat around. And now I was going to put it back together and see if I can find a new owner. This one has a piezo pickup, but it also has 2 humbuckers, as you can see. And on the first iteration, the pickups, we had some way of, I don't know, wedging these things in. I don't know whether it was a great idea or not, but I decided that I wanted some kind of screw adjustability. And I really intensely dislike the plastic pickup ring. I don't like screwing them to anything that I've built. It just seems like wrong, it seems wrong. So I decided I was going to borrow from the Fender P-Bass idea, or jazz bass also, pickup idea, to have a little boss here on the side with a screw going through it. So that's the project I was going to talk to you folks about today. So we're going to leave the guitars for a moment and go over to the machine shop and see what I've been up to over there. I thought I'd give you a look at this funny project I've got going on in my shop right now. This is for a guitar I made a while ago, and the guitar's getting new pickups, and these are black pole pickups from Duneland Labs, Bob Palmieri's fine work. There you can kind of see why they're called black pole pickups. And of course, these are normally mounted with a soldered in plate like this, and then mounted in a trim ring, which I actually don't have one to show you, but here's a picture of one. Although I'm pretty sure anybody that's interested in this knows what a trim ring is. So this is a Gibson style mount from the early 50s. It works pretty well, although I'm kind of grumpy about how they float around like this. I never liked that. On my electric guitar, I did a whole different thing that screwed the pickup solid to the guitar body, which I thought made the pickup sound better. In fact, we did some tests and everybody involved thought it sounded better. I like the pickups to be more firmly mounted that can easily be done with this. Although I will say that you can, sneak in some foam and play around to try and stabilize it, but still hanging it off these little tiny threads from long wiggly screws in a plastic surround isn't really maybe the best solution for getting the pickup to hold still. So scratched my head a little bit, and I thought that maybe I would take a clue from this style of Fender pickup, which has these molded bosses here that are just screwed in like this. So this is the Fender style. They put a block of foam underneath and get adjustment out of that. So anyhow, here's what I came up with, and I'm doing it now, and I thought you might want to have a look. This is a piece of nickel rod. Oh, here's that nickel that it comes from. This is 3/8 diameter. So what I've done is chopped up the rod a little bit and drilled a hole in it with a counter bore. And I thought that this would be kind of a nice look for this pickup. Kind of carries on with the black pole idea, with this thing sunk in there and looking pretty good. So that's the whole idea. When I get these all done, I'll make a little fixture and solder them in, show you how that works. And then we'll see about putting them in the guitar and see how that works. Let's get started on making this part. And this part is 225 thousandths thick and 350 thousandths long. And I make it on the milling machine and the lathe. Here's our stock. And this is going to go in a collet here. This tool is called a collet block. And these are the same collets that I use in the lathe. These are 5C, most common kind of collet for this size work. And we'll tighten up the mounting ring here. And this ring draws the collet into the collet block and securely clamps the workpiece, all right? Now I've selected a side to face out just for consistency's sake, although I have mic'd this and it is square, but what the heck, we'll put it in the same way all the time. So that's what these marks are for. And then I've got a little plate clamped in the vise here for the tool to sit on, the bottom, and another plate clamped in the vise with these two clamps for the block to bump up against. And then we'll tighten it nice and firm so that we hope that this will always be in the same position relative to the table in both X and Y, all right? So you can see there's a little dimple there. That's from the last part that I made. So we're going to mill that off. Now I know that I'm doing this wrong. I'm putting an end mill in a chuck, a drill chuck, and I know a lot of people are probably snickering right now that that's not how you do it, but that's how I do it. For light cuts, it works fine. I make no apology. It's so much easier than trying to change collets in here every time you need to put a new tool in. If you're going to make a little row of parts. For this job, I need 8 of these that are good. I'm not thrilled with the idea of switching collets all the time. I'd rather use this robust and sturdy Jacobs ball bearing chuck. All right. So we're gonna use the digital readout to help us with position here, and I'll find the Z by just touching the part. We'll lock it, drop the table a few thousandths, And I've decided for simplicity's sake to use 1100 RPM for all of these tools. So probably a little too fast for this one and maybe a little too small for the small drill, but it's all close enough to work for me. Here we go. So now I'm cutting out the little dimple. Okay, so that's gone. I'm going to plant the end mill over the middle. I'm going to drop raise the table, pardon me. I'm going to raise the table by 2.5 thousandths. And then I'm going to do that. And so what that just did is it made a very subtle, kind of deliberate mark on the surface, which you can see a bunch of little tool marks that I think are entertaining. All right. Now we'll capture that height level by setting this quill readout to 0, and I'm going to drop this down to the part length plus a few thousandths, which is, like I said, it's 350, so we're going to go to 365. And then I'm going to fire this up at 1100 RPM and make the flat on the part until we get a left to right dimension of 225, that is 0.225 inches. So this is nickel. It machines pretty well. No big drama. Makes a nice chip, and it's not too hard, so it's not wearing the cutter quickly. And we're going to go to 0 on the XDRO. Feed nice and slowly. I'll get a good chance of getting a good cut. And now we'll just, so this is kind of a cockamamie setup in X, so we're going to just make sure that we've got the dimension we want. So we wanted 225, and there it is, a few tenths of a thousandth over. So we're calling that, well, it's better than it needs to be. It could be a few thousandths heavy or light, no problem. All right, so that's the end of our 1/2-inch milling cutter work. And now we just got to drill a hole in it. So we'll start with this little buddy, which is properly called, I think it's called a center drill. And it's because it was used to drill center holes for lathe centers. So the right-hand side of the lathe, sometimes you support the work with a center, which has a 60-degree point. So that's what this is. Sometimes they're called combined drills and countersinks, but since that's not the right angle for a countersink, I reject that. Although, because now you can get them in any of 3 angles. You can get them in 60, what is it, 82.5, or whatever the countersink angle is, and also in 90. So you could do the 90 would let you get a 45-degree chamfer if that's what was specified on your print. Anyway, so here we're moving over to 362X, which is going to split this land that we have left here. So now the drill will come down right in the center of the part, measured from here to here, okay? And we'll take out a good stiff tool, nice and sharp. We'll take it down to about there. You can see it's making a little bit of a 60-degree chamfer there. And that'll be a nice lead-in for our next tool. which is this little drill, which I forget what size this is. But it's to clear the screw anyway. Okay, well this is 116 thousandths drill, 0.116, which if we look it up on the chart over here, we see that's a number 32 drill, 116. Okay. And now, so for depth, the part I said was going to be 350 thousandths in this Z direction. We're going to drill a little bit deeper than that, but we don't want to drill too deep or else we make a big dimple and it just wastes material. We need to find the depth of 0 here, so I'm going to just eyeball this by looking at it horizontally. So I can't see the corner of the drill anymore. Then we're going to call that 0. And now we're going to drill, oh, I don't know, about 400 thousandths deep. Maybe something like 400. All right. And again, it's pretty nice machining material. Quick blast. All right, so I would mention that a lot of these tools that you're not supposed to hold in drill trucks, as I was saying, have flats on them. I don't know if it really matters much, but I like to line them up with a hole, because that means the jaws are not going to get involved with those flats, and they're going to have a nice solid piece of steel to land on, and we'll get a good clamp. Okay, so now this top is clean, and we're going to lightly set this tool down. This is a 3/16 2-flute end mill. Just barely touch the top of the part, and we're going to reset this quill readout to 0. And now we're going to counterbore 80 thousandths deep. Let the screw head sink in there pretty good. So there's 80. Okay, so now we're done with this part in the mill. Now we're going to move it over to the lathe and part it off. So. Oops. All right, so there's our part. You see the cutter had a little trouble with it over here on this side. Probably could have gotten a better looking cut by putting the end mill in a collet. But this is fine for what we're doing. This is going to be a soldered surface anyway. And we'll just sand it with sandpaper, a couple of strokes to make that easy. Okay, over here to the lathe, we're going to use the side of this parting tool to pick up the length. I'll just let it just barely touch there. And now we'll call that 0, so we know how long the part is. Next, we're going to take a pretty little, it's not really a chamfer, because this tool, if you see, it has a radius. It's a radius tool. So we'll set the Y as 0. And then we're going to feed left to this number 224. And so that means that all of our chamfers, or whatever we call this, are going to be the same size. And now, since we've already set our zero with this tool, we can get in there and get the right length for the part. All right, so you can see we managed to not make a bruise on top of the part with the end of the drill, and we did manage to get all the way through. So that's good. And then finally, we'll use these awesome Lindstrom cutters. I'm going to take a minute just to do a quick appreciation for these. Larry Fishman turned me onto these 40 years ago, claiming that they were the only cutters in his experience that would cut flush. So this is a number 7191 Lindstrom cutter, and as you can see over here, they're warning you in big letters, copper wire. So we're using nickel, close enough. At least it's not steel. That's what they're trying to keep you from cutting. And they give you in metric and inches the size, the maximum size of the cut is 1.25 millimeters or 49 thousandths of an inch. So this is much smaller than that. And this is what we call a pip in lathe work. So we're going to lay these down on this surface and cut the pip off. And darn if it doesn't do an almost perfect job cutting that flat. All right? Just like it never happened. All right, so quality control rears its ugly head. We'll have a quick look at this. So we wanted 225, there it is, half thou over, so so the calipers claim. And then for length we wanted 350, we're a thou under, that's fine. And so there it is, and you can see it's got a pretty little chamfer on the top end. And I have to do a little bit of fussing, maybe. How about this? Here's some 320 sandpaper. So there we got a surface ready to solder. Probably don't need it, but on the bottom, we'll just blow away the last vestige of that little pip on the bottom. Okay, so that's a good part, ready to go. Got to make a few more. And I'll see you when it's time to solder these together and make them look good.